Hello. So far, we covered a couple of modeling algorithms related to data mining. More specifically, the predictive type of algorithms. You can divide the data mining into two domains, the supervised learning and unsupervised learning. The supervised learning, where you know what you are trying to predict, like you have a class, for example, you know what is your dependent variable is, what is your y, and according to the independent variables you have, you're going to predict the y, and that's what we have done so far. And that type of data mining technique is called supervised, because you are supervising, you know the why, you know what kind of classifications you are gonna do. The other type of data mining algorithms called unsupervised learning, which is you don't know your why. You have a lot of independent variables and you want to group them in some way, or you want to find association between those independent variables. And you don't know how many classes are going to end up in those groups. Okay, and we're going to look at those in two deep examples, clustering and association, which is a business market analysis, which is very famous in the business domain. So far we covered the correlation, the linear regression, and the logistic regression. Today we're going to start with the discriminant linear analysis. So before even we start with the case scenario we have here, let me just give you an idea what is linear discriminant analysis and how you can use it. So in general, discriminant analysis can help us to cross between classification and prediction in data mining. So with discriminant analysis, we can take a process with the right target attribute in a training data set, which is something similar to what we did in the past. We targeted the second heart attack, for example, class, which is gonna have a second heart attack or not. In the training data, we knew yes and no if that person had or he didn't have a second heart attack. So that's what I meant about targeting the attribute in your training data set. And accordingly, you're going to generate a prediction for the scoring data set. So this is nothing different than what we did so far. It's going to be very useful to know that discriminant analysis is very useful where the classification for some observations is known and is not known for others. So that's a type when you think always, oh, I have to use discriminant analysis. Some classic applications of discriminant analysis are in the field of biology, and okay, forget the science, in business is in the field what is called organizational behavior. So a lot of research has been done in organizational behaviors using discriminant linear analysis. Now, in the biology, for example, discriminant analysis has been successful by applying a classification, for example, to plants, animal species, based on the trait of those living things. In the organizational behavior, this type of data modeling has been used to help workers identify potential successful career path based on personality traits, for example, preferences and aptitude. So by grouping known past performance with unknown but similar type of structured data, we can use discriminant analysis to effectively train a model that can then score the unknown record for us and giving us a picture of what type of categories the unknown observation would likely be in. So that's in summary what is all discriminant analysis. So let us start. So what how we can use it as in our life in as a data analyst in the business domain. So let us start as usual in the case scenario. So assume the following, that Gil, he runs a sport academy which is designed to help high school aged athletes to achieve their maximum athletics potential. On the boys' side of his academy, he focuses on four major sports: the football, the basketball, and the baseball and hockey. So, like any one of us, while using a lot of dealing a lot of similar topics every single day, you start recognizing some type of patterns. So that's what Gail found. So he started to realize that while many high school athletes enjoy participating in a number of sports in high school, more than one, as they begin to consider playing a sport at the college level, they would prefer to specialize in one sport. Makes sense. As he is worked with those athletes over the years, he developed some type of extensive data set. So he was recording what's going on in his sport academy. And this data set has some information about those students. We're going to go in details about this information. And he was wondering if he can use past performance from some of his previous clients to predict previous high school students, to predict the prime sport for up and coming high school athletes. So ultimately, he will be able to help making recommendations to those new high school students to not to play more than one game, but to give them some advice that your profile, your traits, your battery test is highly likely that will allow you to succeed in, let's say, football or baseball. So they will focus on one specific sport early stage in high school, and then when they go to college they will be ready, so they will not waste a lot of time playing more than one game. Okay, so that's in summary what I was telling you. So how is gonna evaluate that? So he's gonna look at the performance across a battery of tests. So this is what he recorded in the past, and now he gets those new students. He's gonna do the battery test for them, but immediately he's gonna compare them to the historical data of his previous high school students who graduated and went to college and played specific sport, and advise those students with the best sport based on their battery test. Okay, we're gonna have the data available for us in Blackboard, so you can go ahead inside your unit to download those two data sets. Okay, so let's from now I'm gonna download the first one, and I'm gonna download the second one, and from here let us, as usual, so I'm gonna copy those. Let's go to desktop, and or the location that you have your data set and previous classes in them. So the BDN repository here, I'm gonna drop those two data sets in them. I noticed that I had this file before, so I'm gonna rename it. As you know, Windows always add those parentheses every time you re-download the data. So training data set and scoring data set. Let us open the training just to see what's going on with this data before even start working on it. So as you can see, we have the age as an attribute, the strengths. So this is a battery test for those high school students in the past. how much they so this is their age, how much they did on the strengths, on the quickness, on the injury, vision, endurance, agility, decision making, and finally what we have here, what happened to those students, where did they end up, what they end up playing in college. So for example, the first case scenario is one student ended up playing in football. Okay, the other one in row 9, also football, basketball. So the idea is we're gonna use this data to predict the new students data. Okay, so this is the scoring data. And you might have guessed it already that we have a similar type of data. I'm gonna select to have to convert it into table. Yes, my data have a header. As you can see, exactly the same attributes, and what is missing here is the prime sport. So he's gonna create a model similar to what we did in the second heart attack. So he's gonna create a model and gonna score this data on that model, and accordingly will generate a new label over here for those students. So he knows, based on the patterns in this data, what is the best fit, for example, for this first student, and what is it for the second student, etc. Okay, let us go back to our PowerPoint. So what we have here in the training data, we have almost 500 observations, and they have the following attributes. And remember, always we talked about that you cannot start doing any type of data mining, modeling, unless you know really the data, what is called the dictionary of your data, what the meaning of strength equal 2, what the meaning of strength equal 10, quickness number 5. So you need to understand your data. First of all, what type of formatting, is it discrete or is it continuous, and what type of modeling data, like is it nominal, is it ordinal, is it character, is it continuous, numeric, is it strings, maybe Twitter, so you have you took in the BDN 310 a lot of exercises covered this type of formatting of data, and you know what type of analysis to apply to them, statistically based. Now we're going to do it in based on predicting what to do with this data based on the data mining algorithm. So look at the data. The data contain age of the students from 13 to 19, so that makes sense. So something to note here, if you look at the data and you notice there is an age 45, that should be a flag. This is inconsistent data with the case scenario. It's not an error, it's inconsistent with what you are anticipating. So applications such as RapidMiner, SPSS Modeler, and SAS will not know that this is wrong or this is an error. You are the one who will discover that this doesn't fit the case scenario of having high school students. Okay, so you have to pay attention to all the stats that we're gonna run in RapidMiner and make sure it is consistent with the case study. The strengths, so it is again a measure the strengths. So during the battery tests, he applied some type of exercises to see how much the strength of the student, and usually it ranked between 0 and 10, 0 being has limited strength and 10 it has sufficient strength. Quickness range from 0 to 6, where 6 being extremely quick, 0 being very slow. Okay, injury, yes, if he had some previous injuries, 0 if not. The vision was range between 0 and 4. So those are discrete numbers, 0, 1, 2, 3, 4. So you remember from your statistics background. So here 4 being perfect vision. Endurance 0 to 10, so 10 representing the ability to perform all tasks without fatigue of any kind. Okay, now agility, this is where the participants score on series of tests, so it's not one test. It's like moving, twisting, turning. This is really especially if you are playing in this in college, you need to have a very good agility number. So it's ranged from 0 to 100, and he found historically that the data he was able to observe in the past, like all his students were falling between the 13 and 80. Okay, decision making, and that's another type of test, a simulation test that they do with the students, such as swing a bat, pass a ball. So it ranged also from 0 to 100. Finally, the prime sport, this is what that student, he was able to bring this data after they left his academy, track those students, and he knew what kind of prime sport they are playing during the college. And we have those 4 categories. So important to note that the prime sport, which is gonna be our dependent variable, our y, has categorical type of information. And since the order doesn't matter, so football is not more important than baseball, so this is a nominal type of information, which is the reason for us to decide that this data is suitable to be modeled using the linear discriminant analysis. So if you notice so far, the focus in the first couple of classes in this semester is to show you a variety of models, but also at the same time to make you aware that when to use each one of them. So if the prediction, if your y is a numerical value, ratio or interval, those type of values, the y that you're going to predict will fit a linear regression model, a numeric output, like we did with the number of heating units the house need to purchase from Sarah in our previous case. Then we looked at binomial type of y, or our dependent variable, and we had the scenario, the class or the predictor, where the second heart attack is a class that has only 2 values, possible values, either yes or no, either that person had a second heart attack or no. So at that time we said yes. So usually, if you remember from your stat, that type of model is logistic regression. So what I want you to keep in mind from now on, every time we see cases, just remember in future when you see data, remember what you are working with this data. What is your y? So if the dependent variable is a classification of more than 2 categories, so if we had only 2, logistic regression will work. However, because we have more than 2 and we want to see the variability between 4 different categories, then you use linear discriminant analysis. So it can weight with high probability which one of those highly likely the student will pick the best for him, according to all those numbers we saw based on the battery test. Okay, so keep that in mind. Okay, the prime store. Okay, something else here. Just a note. uh, all the attributes in this data are numeric, but the prime sport. That is correct. All of them, it's about numeric discrete numbers range between 0 to 100. It's not like a real number 0 0.5, 0 0.7. It's 0, 1, 2, 3. Some of them went to 100, some of them went to 10, some of them went to 6. So all of them are numeric. But the prime sport. So you could also do something called the k-means clustering for this data, and we're going to talk about this in upcoming classes, that you can really group this data based on this similarity in the distance, k-mean distance, which is the Euclidean distance between those attributes, and we're going to talk about that at that time. But keep in mind that yes, you might think at this time that maybe I will do some type of clustering, grouping those people, those individuals. Okay, however, we are not doing unsupervised learning. Remember, I told you clustering is part of unsupervised learning. In the time being, we are doing supervised learning, predicting, so predictive modeling, and discriminant linear analysis is the one we're gonna use. Okay, so we're gonna bring those two datas, and always remind you that when you are trying to score data on a model, your original data, the training data values, should have ranges similar to the data of the scoring, similar to the ranges of the scoring data. So that's really important, otherwise the model will not work. So as usual, our label in this data, and you might have guessed it, is a prime sport. This is what is our Y. Okay. So let us bring the first data and the scoring data. So I just copy and paste just to show you what you have to look in future. Whenever you get a data, you are applying a modeling on it, you have to make sure the ranges are similar. So here what we see, and it's consistent with the concept of the case scenario. Gail noticed that the decision making, remember when we talked about the ranges of the decision making? Here we go. Decision making is between 0 and 100. Okay. However, he was concerned about those decision making because highly likely his students scored really higher than 0 or 3 in his high school academy. And also he noticed that some of them scored even higher than 100. So remember, the range was maximum is 100. So he noticed there's something wrong with this data. So the purpose of doing this is just to show you how you can clean up your data when you are having problems with the data. So we have to pay attention to what's going on in that. Okay, the second data, which is the scoring data. So remember, so this is our training data. We only have 493 because we have the header, so minus this number here, minus 1. So we have 493 high school students. Their battery tests were archived and their prime sport was known. In the scoring data, however, and you can get that number actually easier than that, but we have about 1841. Big number. So really it's interesting. Maybe his business is getting bigger and now he's more efficient to provide those high school kids who has better training, fit their profile to be expert in the college in one specific type of sport. So also he noticed that he has the same problem when it comes to the decision making attribute. So we're gonna try to fix this problem using the filtering operator, and we're going to remove those observations from the model. So when I say remove the observations, I mean this data, since I know this is wrong, so I'm gonna delete all those observations in the time being. There are other solutions, but just I'm showing you one of the solutions is to remove them from the data, especially if the number of those observations are really small. And the rule of thumb on deciding how many observations to delete from your data, if you have missing data or if you have outliers or if you have inconsistency, is the following. At least for every attribute, okay, for every variable you have in your data, to get a good model, you need to have at least 10 cases. This is the minimum. So if I have 10 attributes, at least I should have 100 students data in my training data set, minimum. Okay, now that's good rule of thumb, because if you found out that the decision making range, the wrong one, that exceeding the 100 is you have to delete about 90% of your data, then you would back up and say, no, I'm losing a lot. You might decide to delete the decision making attribute instead of deleting the observations. Okay, decide to read the attribute, keep all the rest of the data, and keep the observations, but not considering the decision making in your model. So that would be one of the solutions. There are many. This is one of the solutions. Now, if we run the analysis, and we're going to see it in the video, you will end up having about 1,767 observations, or new high school students. Let's put it this way. So we are doing what we did before. We bring the data training, we bring the scoring data, we're gonna filter those two because we're having similar issues, and then we're gonna bring we set the role, that is prime sport, and we're gonna bring the LDA model, the linear discriminant analysis model, and then we're going to apply this model to this scoring data, and we're going to see the output. This is the output of your discriminant linear analysis model. It depends how, completely on what is called a priori probability. So based on the data we have in the training data set, a model will be created, and the prime sport is gonna be decided based on those values. And the discriminant linear model, remember the y is gonna be one of those 4 different categories. Okay, so we are talking about 4 different categories, where if you sum up all the probabilities of those students to fit in those different type of sports, your probability is gonna sum up to 1. Okay, as usual, probability is between 0 and 1, nothing fancy. So based on the data we have, the training data, the discriminant model analysis found out that about 32% of those high school students that Gail knew what they are playing in college now, they were playing football. 24% of them ended up playing baseball, 23% ended up playing hockey, 20% ended up playing basketball. Okay, so somehow, why this is important, even this is, we are not applying yet the model, and we are not discussing the applying the model. It is really important when you have a linear discriminant analysis that distinguish more than 2 categories, 3 and up, 3 to 10, you name it, when it needs to distinguish between categories, that the distribution of the output of those categories are really not so far from each other's. So 30, 24, 23, 20, the range is good. Another example, assume you are creating a model to predict some type of, let's say you have a coughing medicine, and you have all the random sampled example in population that you want to see if the coughing medicine affects female more than male. I mean, works better on females than male. Okay, so you have all the attributes, maybe the age of the females, maybe the weight, the height, what else? How long they took that medicine? Did they start it right after they were sick? A lot of information. However, if you picked, even randomly, if you picked in your data 20% of this randomly picked people were female and 80% of your data were male, your model is not gonna work correctly. Your model from the beginning is biased. You bias your model to fit more the male population than the female. So the rule of thumb always in the predictive modeling is to take care of the population you are examining. In our case here, you have to look at the distribution of the training outcome. In our case, the dependent variable. In our case, the prime sport. So if those numbers are not distributed good, then what you will do is you will try to delete some of the entry cases of those high school students that maybe ended up in football. So let's say this distribution was 50% football and then 10, 20, 10. So big problem. So what you're gonna do, out of those the 50, you're gonna delete half of them and then reconsider the data and rerun your model. This is really important to think about whenever you're doing modeling. So the likelihood of an observation landing on one of those 4 categories, this is what is going to be our predictor. This is how we're going to score the data accordingly. Okay, so very simple calculation. So in our data, we had 156 students actually ended football. 156 over 482 total number of high school students. That's how the probability was calculated. Very easy. Now we gotta apply the model on, so this is the LDA model we just saw, and we're gonna apply this new student, high school student, to the model and tell them and their parents that they should pick that specific sport. Here's the output of our data. The output of our data is telling us, and there's some changes to that look of RapidMiner. So at the time I'm not going to discuss it, but you're going to see it in upcoming videos. Just to mention the following. So, for example, the first student over here that has his age about 18 years and a half. He scored 5 on the strengths, the quickness 1, injury 1, etc. The model, the LDA model, predicted that that student should play basketball. Okay? And for the second one, was age 13, strengths 1, 2, 1, baseball, and etc. Now, in upcoming videos we're gonna see that not only we're gonna see the prediction of the new data, scoring data, we were gonna see how much confident the model with that prediction. Is it 90% as basketball, 40%, sorry, it's 90, okay, 30%, let's say basketball, 10, 10, 10, okay, it should sum up, sorry, okay, so 70%, let's try again, 70% as basketball, 10 for baseball, 10 for hockey, 10 for football. Okay, so that's how you're gonna see them, and we're gonna run and we're gonna see some other type of model with those confidence. Okay, that's amazing. You know, the power of RapidMiner that can predict for you how highly likely that you are giving a recommendation to a student to focus on a specific sport. That's really impressive, very impressive. And the confidence level, that I don't like the numbers here, that's 0, we're gonna run it and see again if they had some issue in a period of time with LDA, so it doesn't show all the results. But however, there is another way to see those results. We didn't learn how to split data and to validate our data. This is, we're gonna see them in upcoming evaluation modeling. My goal at the time is just to make you aware of those models in data mining and decide to get the habit. Every time you see this type of a problem, that categorical dependent variable, you have to use linear discriminant analysis. So that's my goal in those beginning videos, and then we'll go in details and dig deeper in those cases. So what else I put? Okay, so in some predictive models, your data will yield partial confidence, what I would say, such as like 8% confidence for football, 96% confidence for baseball, 12% hockey, 11% for basketball. But because the 69% is the highest, so you're gonna recommend that student to play baseball. So it didn't occur this in this data. We're gonna revisit this and we will see when we split the data that will solve that problem. Okay, we call that specific variation across this type of specialization in this battery testing score, because this data really somehow it has this type of categorical type of information. Really, LDA is the best fit for it. Okay, so the note here, that doesn't mean if you didn't see the confidence percentage that our experiment was a failure. No, don't worry about that, and be confident that based on the pattern in the LDA model, that's what you're gonna come up with and your model is correct. Okay, evaluating the model, we're going to talk about the evaluations and how we evaluate models. I will leave it to after looking at some of the most of the models in this semester. So that's it about discriminant linear analysis. It's really cool, you know, so you will be able to show your you know, if you are working as a data analyst to Gil and give him those results, that definitely is gonna be interesting. Okay, so let us run the data now. Okay, let me stop that and let me close this data. Yes, it doesn't matter if I had libraries. This is my data here. Perfect. I'm gonna start with RapidMiner. A note here, you really have to close the Excel files from before you using this data, because most of the time you will get an errors if you don't do that. So pay attention that always when you are examining, I'm gonna postpone, when you are examining your pulling your data into RapidMiner, close Excel dataset, otherwise you will get some error messages. So let me start with our repository here. Up to you, you want to add it here or you want to create a new, it's up to you. All I have to do now, I'm going to bring the data, add the data, and as you saw, I put it in the repository, and this is the training data, the first one. Okay, make sure there is a header defined. Some of you had issues with one of the examples, so the header is defined at number 1. Okay, and you can change the attributes from here. So as you can see, it took the age, so maybe I will say this is since it was counted here, so I cannot change it actually to date. It's not a date, it's a really a real number. And you want to round it, you can change it to integer, so you will have an integer number, so no ratio there, so it's okay. Strings is integer, all of it is integer. It's not gonna matter for the model, but let's do it. What else? So this is polynomial. This is how RapidMiner call the nominal type of attributes. Okay, and finish. We can see the data now. This is our data, the training data. Of course, as usual, we're gonna look at the statistics, make sure there are no missing data. Look at the histograms. You're gonna open the histograms just to take a look and see what kind of distribution you really have. You want the strength distribution, more like a normal distribution, a bell-shaped distribution. Quickness is skewed to the right. Okay, we're not gonna take care of those, it's okay. And the injury, so 0 1, that's why it's categorical here, you can see, but it's given 0 1 in our model, and we're gonna leave it like this. The vision on 4 distinct discrete values, and endurance, ability, as you can see, the range to 80. Decision making, this is the one that we said that have an error and a lot of zeros here, so we're gonna fix that problem. The prime score, those are the 4 categories, and you can see from here the distribution of those categories, you know how many. So we have almost 160 here, maybe 17, 116, and here we have 100 playing basketball. It's good habit always to go over this type of analysis before starting modeling. The problem we said we're gonna fix is the decision making. We're gonna filter everything less than 3 and everything bigger than 100. Okay, so we're gonna learn how to do that. Let's go back now to the design view and bring the training data over here. I'm gonna bring the second data. You can use last directory, easier. LDA analysis, I called it. Make sure it's on the number 1. And since we changed this one over there, I have to change it here. Remember the rule of thumb, data should be similar to be able to create a model. Similar I meant range wise and similar type wise. Okay, and that's it. And as I said, good habit to see the ranges. So 13, okay, let's start one by one from 13 to 19. Let's keep the statistic. 13 to 19. Okay, so perfect. 0 to 7 is the strengths. 0 to 7, the same range. Quickness 0 to 6. 0 to 6, perfect. So let me close those if they are confusing you. Injury, we know it's 0, 1. Vision 0 to 3. Let's see both. 0, 1, 0, 3. And then endurance 0, 6, 13, 18, 80. So that's perfect. So the only one we have problem with is this range here, the decision making. Okay. And okay, I have to mention here, since this is categorical data, you get the bar chart as as your histogram. Instead of histogram, continuous histogram, you get those bars because it represents the categories. What else? You can see the distribution of this categories. As we said, those are the distribution of the numbers of data. Always good habit to start with that before even creating a model. Okay, so this is our scoring. I will put it over here. Now our next step is to filter. So we are going to use what is called filter, the operator called filter examples. Okay, and there are many. This is a new one there, so you might use it range if you feel you are more comfortable with it. I'm gonna click on add filter, and technically the filter I'm gonna using is for the decision making, and all I have to say, I want everything that is bigger than 3 to be included in my data. I'm gonna add another entry, the same one. That's why I said I see the range is available. I could have used it. It's okay. Everything is I want to include that is less than or equal to 100. So another misconception with RapidMiner people make, that what you are filtering here actually you are keeping. Okay, so what you're saying here, I want all the data that has a decision making value bigger or equal to 3 to be included in my data. Okay, and decision making that is less than or equal 100 to be included in my data. Anything else will be filtered out. So somehow the name filter, you will think, I'm filtering those, I don't want them in my data. That's not correct. Okay, so just to make sure you understand what I meant. So let us try it before continue, and I'm gonna save my process over here, store process here, and I will call it LDA, linear discriminant analysis. Let us run, and as you can see, not this one, yeah, sometimes make sure that you close everything before you run it. So let's go back, run. Okay, the statistic. So now we have what Gail wants. From 3, our data distributed from decision making equal to 3 to 100. Okay, and that's simulation type of decision making, gaming maybe, that based on it they decide how much the student got. Now since I'm gonna use the same one to the other one, I'm just gonna copy it and I'm gonna paste it. Simple like that. Okay, I know it works, so I'm not gonna repeat. Now we're gonna bring the model. Before bringing the model, we're gonna bring the label, and you can do that also when you bring the data. We mentioned that before. So set the role, and from here I am telling it that the prime sport is my Y. Okay, so this is my label. Okay, now we're gonna go and just write LDA, linear discriminant analysis, and under the predictive model. So let me bring the model. Okay, and of course if you are interested to learn more about LDA, you have a lot of help here to tell you exactly what it does. Okay, so if you heard ever about principal component analysis, so it's some type of let's put it in this way, it is a way to use or to look into a different type of classes that there are patterns that can distinguish them. The principal component analysis is used to find just the opposite correlation in the data, in which you can use to take out of your data. If you have a lot of attributes, that's what the method you will use. So you come up with some type of eigenvector, and based on those who are the highest one, that's the one you're going to use. So you will be able to see the variability in your data in a better way, which will lead to having a better predictor model. So please try to look into those, and also there are some examples in RapidMiner to help you to look into them and to see more in details how you can adjust those based on the case scenario. So before even going further, see, I'm just creating a model. I'm not scoring in the time being. I'm gonna run, and that's the output of my model. So it's based on a priori probability, which is we know what are the percentages of the data. We gonna score the new data accordingly. Okay, now after this we're gonna apply the model. So just apply model, and it's under scoring. Always remember, this is how it works. You have a model, you bring the model into apply model, you have data that are unlabeled. Okay, as you can see, those are unlabeled. We don't have label yet. And you're gonna drag it into the input that says unlabeled, and the output will be this data but labeled. And if you're going to look at your model, you can look at your model as well. We are using a very simplistic way to create predictive modeling. You might want to exceed your knowledge and looking into those boxes and see the formula behind the scene. We're going to touch those a little bit in upcoming classes. And just to mention, it's supervised learning type of modeling technique used for classification, to classify between different type of categories. So that's the domain. Let me save and let me run. Okay, so this is the output. So even they removed those zeros. Remember the zeros I was telling you I didn't like? Okay, so this is how now the output. And always when you have colored output, this is will become type of special attributes in RapidMiner. It's different than the regular attributes like those. So according to this, the model, the predictive model, predicted that this first student is gonna play basketball. That's the best fit for him. Baseball, the second one. So let us look at the stats and look at the distribution in those. Okay, so not bad. So you notice the distribution is not similar to what we have. It doesn't matter, it's looking at the patterns in your data. That will tell you the story here. So you can see from here, it's telling you actually, see the output based on this data. 50% of the students in this data had a profile similar to those 30% we had in our training data. So 50% they had patterns similar, and those were gonna be recommended to be a football player. 26 baseball, 14 hockey, and 0.08 basketball. Strange to me. So of course it's gonna add up to 1. This is probability 0 to 1, and the absolute count is how many of those really ended up. So from that number 17, what was the number we had? 1700 something. Okay, 1767. Out of those, so if you divide 1767 over 894, or 894 over 1776, you end up having that number, the 50%. The 50% that students ended up with football. Okay. Now it would be cool if we just pull the output. Okay, let's have this output. So I'm not gonna look at the model, just I want the label. Okay, I'm gonna write it in Excel file, and there is a way to do this. Right, Excel. I'm just gonna drop it here, and I'm gonna decide where you want to put it. Last directory here, and I'm gonna call Gale recommendation. How about that? Gale recommendation. And it's gonna have the Excel output. Run. And I'm done actually with Excel. I'm gonna close it. You guys save the changes, and I'm going back to our repository, and I'm looking at this Gale recommendation we just created. So RapidMiner created an Excel file for us now. Let's open it, and guess what? Those are the new high school students, 1767. Insert table. Yes, I have a header, and guess what? Those are the new students with a prediction for their future or the best sport to get fit for it. Amazing. So this is how important data mining is. You can, in this case, you are saving a lot of time, a lot of energy, a lot of focus on many different sports maybe your son or your daughter likes, where you can make him or her fit for the best sport that fit her profile. And the profile is based on those battery testing that has been done in this first week when they went to Gale Academy, Sport Academy, and accordingly he's gonna focus only on those sports. That's it by now, and you will have an exercise in upcoming classes. We're gonna see more details about what's going on behind the scene, how the evaluation is gonna be made, and which models we're gonna use, when sometimes we can use more than one for the same type of problem.